So all my parts are cut, and now I've got to start machining them. So what I'm doing here is I'm just flattening this edge off. So what I'm doing is just bringing this down to here. All I've done is offer this up to every single block. Got plenty of room round it to work, and I'm just doing a quick scribe up here. I'll see if I can, yeah, you can see that scribe line where it finishes. So all I'm doing is just putting them in the vise and just flatten it off like this. Right, so hopefully I've got you in a decent position. So this is not critical, I'm just purely going up to that scribed line, but from that I've got a datum point to start from everywhere. So like I say, I've got you in a position hopefully where you can see the best shot of this little manoeuvre. Right, so the next operation, as you can see, I've already done one, and that's the way I'm going to proceed anyway, so I can actually concentrate on what I'm doing rather than the camera. And then once I've done each step, then I'll start filming. Right, so the next step is this surface here. This machined bit here, forget that, I was just thinking out loud, but ignore it. So this surface here, the distance between this edge and where the curvature starts on this is 42.53 mil. So this one I've done at 40 mil. Now what I'm going to do in all the other ones, this height here is set at 8.5 mil, which is what this is. The others I'm going to do it slightly higher than that. So when I machine this curvature, which will be like this effectively, I'm using this milling cutter you can see in the background here, yeah. that curvature I will do, and then I'll just mill down this edge to bring it to final dimension. Where the first one I've got it to final dimension now, but that's the way that I'm doing it in future on all of these. So I'll probably do it, say 9mm, so it's got half mil to come off it. That's the idea anyway, so we'll see. So flat area, I can then drill it, and what I'm going to be doing, I'm going to be doing it slightly differently than the test model, because the test model I've done this, put the tapers in, fixed it that way. On these I've decided I'm going to drill it and tap these holes, so I bolt it on effectively using the thread of the brass. Reason I'm doing it like that is because I can machine all this without worrying about any tapered screws, fittings or anything. So right, let's do it. Right, each one of these is sitting on a homemade parallel, which basically I've machined up to suit this. I've got a homemade square, which is no more than a bit of brass that I've just rubbed flat with a file, and it is pretty flat, I reckon. Flat enough for what I need here. Offer that up, bump it up against that end, bump it down till it sits on the parallel, because it's not sitting on it yet, and then get machining. So I'm going to do that, and I'll bring you back in a minute. Right, so I've got a depth of 9mm from the bottom of the part to this area here, and we're going to machine that off. The distance I need to cut is 42.5mm, give or take, and that of course is minus half the width of the cutter, which is 12.31mm, which is half the distance. So obviously the 42.5 is minus that. Right, this is yet another little detour. This is one of the fixture plates that I've got, and as you know, that bolts on there. You can do some machining operations, do the drilling here. So that was the idea of that one. But what I'm thinking now is I wanted a fixture that I can put this on the rotary table, and I can mill along here and then turn the rotary table and mill here. So this is the new fixture, or will be. I'm using aluminium because I've got some decent size and it's going to be plenty strong enough for what I want. So there's my stop, pretty much like the other one. I had a stop. There's a stop. Going to drill it, and I will put a screw or a pin or something here for a dead stop that way. So all of these will be able to bolt on exactly the same place, and then I can possibly mill the top off these, as well as mill along here, rotate it and out again. I might even be able to drill this hole as well, but that's what my thinking is at the moment. And it's purely and simply that I quite fancy being able to do this, rotate it and off again in one move, or should I say in one go. So I'm going to need a couple of holes. Just swing around for a second. Right, so the idea is that I will put a couple of bolt holes down through this that I can bolt into the T slots, nuts. I will then have this component situated in the right place. So I've still got to work all this out yet. But ideally, my milling cutter will be here. Let me just get a milling cutter just to demonstrate. It's not the right one, but for instance, my milling cutter will be right, that's in the corner, and of course it's going to be above the centre of this. So I mill down here to a measurement, rotate the table and then mill out. That's the idea, but I just fancy the idea of just doing this in one move, or one motion, or one step. You'd have thought by now I would have worked all this out, but every time I look at it I keep thinking about something different. Maybe that's a bad thing to do, but there you go, that's what I'm going to be doing next. So it's a matter of working out where this all works out in relation to the T slot. I can drill them, and then of course I've got to make sure that this is in the correct spot for these fixings as well. And once that's done, I can then put a stop in. All sounds easy, doesn't it? No, it isn't. Right, okay. I'm not going to bore you with all of that. I might show you a few operations, but you know where I'm going. I don't know where I'm going, but you know where I'm going. Probably to hell. Anyway, right, bring you back in a minute. Did I need to drill all the way through? Probably not, but it doesn't matter, and I'd rather have a knowledge that the tap's gone deep enough without me bottoming out. Right, before I move anything else, let's put the tap in and just get that started. Right, head diameter of the bolt, 8.9 mil.